This was made in Hueforge. Most of you don't need an introduction to Hueforge, but if you do, it's a software for turning pictures, as in image files, into real-life images, as in 3D prints. Which sounds odd in itself, but it's a real phenomenon, and it kind of makes sense, and it's quite popular. But only around a couple of % of you who responded claimed to understand how to use it beyond basic competency. In this video, my aim is to show you how to use Hueforge, but also how Hueforge itself works, how to pick the right source images for Hueforge, that's important, and also how to use Hueforge to print in colours that you don't even own. All that in about 20 minutes, it's a tall order, let's go. This video is sponsored by PCBWay. If you've used Hueforge at least a little bit, you will recognise the interface, although if you haven't used it recently, like I hadn't when I came to make this video, you will actually notice the interface has changed, and quite significantly. There's no sliders for one, and depending how long it's been, there's a new central bar as well, showing you the colours in lieu of where the sliders were. As a side note, they are still there, they're just really not needed anymore unless you're used to them, so you can turn them back on if you want to use them. The picture on the right is always the input image, and the picture on the left is the Hueforged image, a pretty decent representation of how the print will come out. That is, if you've set your filaments up correctly. We'll talk about that more in a moment. The process of making a Hueforge is fundamentally thus: import an image, pick some colours from the list of filaments that you actually own, drag the sliders a bit. At its most basic level, that's all there is to it, and that doesn't seem very hard, does it? If we ignore everything else. If you drag the sliders a bit, you can kind of get the feeling that the darkest colours are at the bottom and the lightest colours are at the top, and if you swap that around, it makes the image look pretty weird. As long as you don't mind these kinds of images, especially the sepia or monochrome types, then you really don't have to do a lot of work to get them. But then you look online and you suddenly realise that there's people out there making things that you can't figure out how to make, and they are also using Hueforge, and you want to know how. I want to emphasise that there's no right and wrong in the software, Hueforge, or the process of making these things at all. In fact, as you'll hopefully see in a moment, this kind of Hueforge, where you get these kinds of images out, is one of the rights, and it's an expected output for this kind of input photo. But clearly there's some other ground to cover to get from this to this. And the first bit of ground I want to cover is how Hueforge interprets your image in the first place. One of the main frustrations everyone is going to hit pretty early on in their filament printing journey is that they go out, they take the perfect photo, or they just find one online, and they put it into Hueforge, and when trying to assign a colour to a seemingly obviously coloured part of it, Hueforge seems to have a mind of its own, or rather, its own interpretation of which parts of the image should be coloured. This confusion comes from the way Hueforge, in what I will call its classic modes, not the ones using the word colour, we'll get onto that as well, but because of the way that Hueforge understands images at a fundamental level. It is time to talk about luminance. Every one of these images that you can see on screen has a fundamental problem for Hueforge. You, assuming you have relatively normal vision, you can pick out the subject from the non-subject from some of the pretty obvious information in these pictures that we are hardwired to really consider first and foremost, and that is the colour information. If I take that colour information away, assuming you do have normal perception, what do you see now? You're probably still smart enough to figure out the subject of the photos, but that's far less obvious without the colour information. You're having to actually use your brain to try and figure out what's in the picture now. So given that I'm doing this, you've probably worked out by now that Hueforge classically interprets pictures from their luminance. This is how it assigns colours to your image. Luminance is literally how bright an image is. You take black at one end, you take white at another, and you just figure out where on that scale the pixel in question is, and you assign that a luminance value. So on a personal level, I knew how to tackle this. Most modern cameras and higher spec modern phones have dedicated profiles in them to shoot in black and white mode to varying extents. I especially like those devices that would go a little further and replicate old film. Again, this is quite common. What happened when I did this was actually quite subtle. Black and white images are essentially just made up of luminance data and contrast. Contrast can be seen as the lines in the photo, the pencil you draw with before you colour in, and luminance is the colour. It's all the colour, but that's why this works out to be such a good map for Hueforge. And just to make it abundantly clear what's happening in Hueforge, when you drag a filament to the bar in the middle, you're mapping colours to luminance values. And when I switched to black and white for acquiring images, I found that I was able to see what made an image that would colour correctly in Hueforge. I was able to go from taking a bunch of images and thinking that maybe I would have to edit them in Photoshop, or maybe I would just have to throw like half of them, well, probably about 90% of them out because they just didn't work well in Hueforge. I went from that to taking images that I knew would be almost certainly suitable every time. You could start to get a much better idea of what's going to work and what's not going to work. In a way, I think it's quite ironic that to prevent being constrained to these sepia-style outputs, you have to go out and take images in monochrome to be able to have a vision of how the colours will work later. This is a red filter. It's the only colour I have at the moment because surprisingly I don't actually do this a lot yet. Perhaps I will. If you stick a red filter on your camera and take pictures, they look terrible. I mean, they look interesting, but they look terrible. That's because red filters are from a time when we didn't have colour film. If you're older than me, I have actually shot on black and white film and developed it, but I only did it ironically. It wasn't during the actual time when that was a thing. But you might have owned these filters in red, orange or yellow, or all three. When you apply them to a black and white image, even today, what happens is it turns things black that weren't necessarily before. So it's a good way of adjusting the background. It will turn the sky dark. It will turn green leaves dark. Some select cameras like Fuji have built-in modes that simulate a red filter, so you don't need this one. Others have a high contrast mode that it doesn't do the same thing, but it gets you a more usable image in my experience. These are not things that you can use for every image, quite the opposite. If you're photographing a grey squirrel on a grey path, then you're not going to be able to red filter your way out of it. And really sometimes the answer is to ask AI to cut out the squirrel's head for you, which it can. And on the topic of AI images, they work really well with Hueforge, and there's a good reason why they do. Even if you aren't prompting deliberately for an image to use with Hueforge, which you can, AI surprisingly understands Hueforge quite well, but by default out of AI you still tend to get images that are both deliberate and clear. They are very kind of artificially composed, as opposed to real life, which is frankly anything but deliberate and clear. After everything we've just talked about, there are newer modes in Hueforge that are subsequently aware of colour. The most commonly used now, so the one I'll show you, is the most recent, which is colour match mode. The name gives away that it's matching colours, but not specifically what that means, and colour match mode is probably the hardest mode in Hueforge to get your head around. But let's have a go, and I guarantee that you will understand it in a moment, because there's something we need to talk about first, specifically opacity and blending. What I've printed out here is a strip of colours. This isn't made in Hueforge, this is just the intrinsic behaviour of filament. I want you to understand that blending filaments isn't just lightening and darkening them as we do in those sepia photos we made back at the start. The colours at each end are real colours, the same colours as the filament. The ones in the middle, they are not. They are derived colours. These colours do not exist in this sample. They're the product of light passing through the first layer, hitting the second, coming back through as a reflected colour, and then being filtered through the top layer again. So this is a process that doesn't represent mixing pigments, because this is a combination of reflection and transmission. And also, if you took the plastic layers apart in here, there's no part of it that's the intermediary colours. This is blending in Hueforge. You can easily see how this applies to black and white by putting a gradient source into Hueforge and processing it as normal. The output has the real filament colours at each end, as you would expect, and it has non-existent greys in between. I guess it's not that surprising to see non-existent greys, but this opacity needs to be quantified because filaments differ hugely in how much light they let through, even when they might appear to be the same colour when they're on a reel. This is where the concept of TD came in, which stands for transmission distance. It's a proxy to opacity, but with a very specific definition. We'll get to that. What feeding TD into Hueforge allows it to do is more accurately predict the derived colours, and whether they'll be present at all. In fact, it can also predict when your layers are thick enough to be fully saturated, and it indicates that on the bar with the kind of equals sign. Measuring TD has been somewhat of a technological evolution. Last time I covered Hueforge, the available means was a cup that you put discs into that built up to the right thickness that you put up to the light. And that is its definition, so it's not a terrible way to measure it. But the problem is with some of the filaments having TD values too thin or relatively thick, it's a lot of work and it's also relatively subjective to an extent. And when I say subjective, I mean it. I want to check if you're still awake at this point, so let's have a quiz. You might want to get some pen and paper for this one if you want to be truly dedicated, because you're going to have to write down some values. I've designed these discs. I'll probably not explain why in a minute. You can, in theory, put them in front of light to see how much they let through, but at their thickest, they're probably not going to be enough to stop all the light for, say, a white source. You would probably need something more like this, which uses a lot of filament. But what I want you to do is write down what you think the TD value is for each of these discs that I'm about to show you. I'm going to number them for you, and remember TD is the distance in millimeters before no light gets through. So it's also the minimum thickness that you need for the sample to be effectively opaque to backlighting. I'll give you a head start. The sample on the left has a TD of 0.5 and the one on the right has a TD of 7.0. Good luck, you will need it. Okay, pen and paper down, for those of you who actually bothered to get one. How did you do? I'm genuinely interested to see what kind of intrinsic gut feeling people have and whether it's colour dependent, so make sure to let me know in the comments how accurate your guesses were. But what I really want to know was what your answer to these two was. This is what I would have guessed. The thing is, opacity is not a value, it's a function of what's behind the sample. Which is problematic generally for Hueforge, but it's especially problematic if you're measuring your sample over a different colour to the one Hueforge is expecting, which is black, by the way. A lot of people are using white because it's easier to measure through for this kind of sample, as you can see, but it tends to show filament through much more effectively, and that's fine. Hueforge knows this, and it's able to deal with it and predict how it's going to work, but if you do this yourself to get the TD value, you're effectively giving incorrect data, and you almost might as well just not bother, possibly. I graphed both to see what the difference is. This is observational data, and it's pretty obvious that you can see different values in most cases. The most foolproof way to measure TD is with one of these things. This is a BQ-TD1S. Or is it? This is a BQ-TD1S. This has a light sensor and light source inside it. It's an off-the-shelf solution, and I think you can build your own, but these are available from BQ. But these are not cheap, and I accept that if you're not like super serious, especially not initially, about Hueforge use, then it might be something you don't want, especially considering it's quite a bit more than just the price of the Hueforge personal license. So I also graphed the values that I picked by eye against the TD1S, to see how accurate that I was, and you could see how accurate you were. I found that, except for purple, weirdly, I didn't score that badly. I think if your skill level at doing this is high enough, at least as good as I am, then I think you might be able to get away with doing this by eye, but I personally don't like that it's subjective. It's a lot easier if you can just stick the piece of filament into the meter and get the value out, write it on the spool, and do it that way. Now we get back to colour match. Colour match is essentially the solution to the problem we have with multiple different real colours on the source image being picked up due to having the same luminance. But colour match is a lot harder to use, as I mentioned. Actually, it's not that hard once you've had some practice. You can get very good at it very quickly. What you need to know here is that colours in the right-hand bar correspond to the source image, which is on the right, and you generally want to drag colours from your source image using Control and drag with the mouse. Figuring out which colours matter to put on your bar is more art than science, but every pixel of your source image gets matched using the algorithm here to the closest part of the right-hand bar, and you can ultimately tell what that is because when you hover over parts of the image, it flashes which part of the bar it matches to. I find this is a really good visual indicator that helps you build up the bar and gets you coverage of the entire colour range of the image, which is what you're ultimately aiming to do. And as you get more experience at doing this, you start to know which colours to put at the bottom, which to put at the top. Colours that are at the bottom of the bar will be printed at the bottom of the image, so they'll be printed first at the lowest layers. So that can be an aesthetic choice, but it can also save your filament if you have highlights up at the top. You get the idea. But also some colours you don't want to mix with each other or you won't want to put next to each other because they don't blend well. And you can leverage that to get your derived blended colours or to avoid getting derived blended colours. For example, if you know you need to blend to get a green, then your mesh core needs to be mindful to put green between blue and yellow so that when you come to the left bar, you can blend that. Whereas if you stick something like a red in between blue and yellow, then you don't get a green space on the bar at all. And so green is just going to match wherever it feels like. From the right bar to the left bar, it's kind of like working as a lookup table of which filaments to use on the actual print. This bar is where you say, use these filaments to achieve the colours that are in the right bar. So not only you can instruct it to blend the colours, as I've been talking about, but you can also remap colours entirely. For example, you can map red to green. There's a lot of flexibility in having the two bars that you don't get with one bar. And you can build the image up quite deliberately using the tricks like blocking the blending with white or black, or you can just use an opaque layer so that the next layer up is more bold. And as a practical demo of the whole process from start to finish, let's talk about today's sponsor PCBWay. While I use a partial screenshot of their page as a live demo, it's about the right level of complexity to really show you how it works without getting too far into the weeds. What I'm doing here is dragging the principal colours as I see them onto the mesh core. As I told you just now, it's always easier with flat coloured stuff like this because you have very discrete colours, so you could just drag the colours that you see onto the bar. I've put blue under green, which might seem a bit weird, but the tiny bit of blue there is in the header and it fades from green to blue, so if you put that next to green it will do that rather well. And then after the green, I'm going to go to black to cleanse the palette, so to speak, and then grey goes to orange. I'm not really particularly applying any science to this, it just feels like it should go that way. And then I'm going to put white on the top. Once the mesh core is correct and it looks okay, you can click on the colour core and then you can build that up. And depending on how many colours you're willing to use, you can solve this quite well with 7 filaments or reasonably acceptable with less. I think that's actually a decent result personally. And on a more serious note, if you do need any PCBs made, you can't do that with Hueforge. I don't think. You can certainly pretend, but you can't actually do it. But you can make PCBs with PCBWay, and it's pretty easy to get them ordered using their easy order page, where all you have to do is upload your Gerber files, which is what a PCB design software creates. It's a very seamless process. Check out PCBWay in the link in the description, where there is also a first-time user coupon. Thank you PCBWay for sponsoring this episode, and let's continue with how colour match works. I realise that some of that might have seemed quite hard, but what I suggest doing to try to get to grips with the concept here with colour mapping is to try to map various images to just black and white and the 3 primary colours red, yellow and blue. The reason most people don't do this, and the reason why it's not necessarily a good idea to do this on your Hueforge images, is because the pigments are not as bold, and you can see it looks quite dull, and sometimes the mixing just kind of doesn't look that great. But in terms of learning how the process works, and how the mesh core represents the image colours, and those are then approximated by blending colours you're making from filament, this won't win any prizes as a Hueforge image, and you end up with a lot of colour swaps. But what you're going to get out of this, if you spend some time doing this, is you're going to understand how this works a lot quicker, I think. So now we get finally to the point of the video. It's really not the point of the video, but it was the initial premise of the video. But as usual, we ended up down a huge rabbit hole. There are now plugins in Hueforge. One of the plugins is called Hueforge, with a G in it. And it makes, well, the hint is in the name. I haven't actually yet made, as in printed out, any of these because it's a lot of work. But maybe by the time I've finished editing, I will have printed one of these out, in which case I'll put it on screen. I've instead been spending my time on the second plugin, which is a paid plugin, which is called Flatforge. I'm not sure if all the plugins are going to be called something funny and then Forge, but I feel like the precedent has been set, so maybe they have to. Flatforge is interesting in that it flips the Hueforge upside down and prints it flat, as in flat. The thing is, if you print it upside down on the bed, you have a thick first layer, or rather you have to have a thick first layer, because most printers are pretty terrible at sub 0.2mm first layers even now in 2025. So even 0.16mm first layer is pushing it when you want it to look nice. So what Flatforge does, and I guess this is optional if you think you can do better without it, it puts a transparent first layer down. Transparent, kind of. You need to get hold of something called natural PLA or transparent PLA. That is, if you're printing PLA. It's not typically fully transparent, it does depend on brand, but it's close enough at this thickness. This stuff is Sunlu, and it's okay. Because of the fact that Flatforgers are putting more than one colour on each layer, they absolutely do need a colour changing printer. You can sneak extra colours by swapping them in after the clear layer, and you can do this on a tool changer as well. You just pause and unload and replace all the colours. But on a Flatforge, you kind of just have to use what you have, because every layer needs all the colours, or potentially. I suppose that makes sense. It is called Hueforge, after all. If you have a Prusa Excel, I guess you can get a copy of Hueforge. And on that terrible joke, I think I'm done. Hopefully, I've done a half-decent attempt at making you feel like you can now approach Hueforge. I know it's impossible to go into absolutely everything, but hopefully, once you know enough, it's not as scary anymore, and you can have a go and you know what to search for, and it's a lot easier to get answers. And that's where I want this video to get you to. Any questions, stick them below. If you enjoyed this, then there's at least 2 buttons down there for that kind of thing. I will see you next time. Thank you for watching.